Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 70, climbing stairs. This is an easy dynamic programming problem. We're told that we're climbing a staircase. It takes n steps to reach the top. Each time we can either climb 1 or 2 steps. And we're asked how many distinct ways can we climb to the top. And we give an example where n is 2. There's 2 ways to climb to the top if n is 2. It's taking 2 individual steps, we just jump in 2 steps. And we give another example where n is 3, where we can take 3 individual steps one by one step, and then jump 2 steps. Otherwise, jump 2 steps and then take 1 step. So this is, if you've solved Fibonacci before, this is basically the way you solve the Fibonacci problem. But today I'm going to look at another approach, and it's computation. It's theoretically pretty similar, but we're gonna be using a decision tree, using a depth first search approach, and I just find that it's a slightly easier way to visualize in your head these kind of problems when using a tree. So let's get coding. Let's create a depth first search function, and let's create a parameter called ACC, which is going to be accumulated, like our accumulated result so far. We're going to say if that accumulated result is greater than n, then we're just going to return 0. Otherwise, if that accumulated variable is equal to n, then we can return 1. And then what we have to do is do this recursively, so we return depth first search accumulated plus 1 plus depth first search accumulated plus 2. And then let's return depth first search, and let's start off obviously at 0. So let's run the code. Let's check if it works. And it works. Now let's submit our code. And I'm gonna wait for it to finish judging. But if you've done a dynamic programming problem before, you know we're gonna get a time limit exceeded error. And that's because our result can grow exponentially with the amount of different permutations we have, and it's just not efficient. So we need to introduce something called memoization, and that's basically by caching results that we've, and then using our cache if we come across similar results or similar decisions in our decision tree. So let's implement our cache, which is say to a Python dictionary, and now we just need to add another line. We're going to say if our accumulated variable is in, or our accumulated result is in our cache, then we can just return the result in our cache. Let's change this to elif. Otherwise, we will set our accumulated value in our cache as the current, as depth first search plus 1 and plus 2, and then just return the cache value. I mean, we could store this in a separate variable and then return it here, but this just makes it simpler. So we return the cache variable, and now let's run the code again after having implemented our cache and memorizing our solution. And there's a typo that I've made. And our solution is accepted, and it's pretty optimal. So that's our DP problem using memoization. In terms of time complexity, we're looking at an O of n time complexity, and space complexity is going to be O of n as well, because we are using dictionary and also because of the recursive call stack. So both time and space are going to be O of n. So I hope you guys enjoyed this video, and I'll catch you in the next one.